Hey everybody, welcome back to part 3 of the Unit 4 review. This video is going to be very similar to the other videos. I have everything worked out ahead of time to save time, but I'll explain to you how I got everything. So 10a says given the table, write the quadratic equation that best represents it. So I need to plug this table into Desmos. To do that, you open up Desmos, add item, click add table. Once you do that, you can plug in your values. And then in the next line, you need to type in your regression function. This you have to have memorized. The y1 is approximately equal to ax1 squared plus bx1 plus c. Once you type that in, this other information will automatically display. So what you need to pay attention to is the a, b, and c. A is -2, b is -4, c is 11. So plug that in for ax squared plus bx plus c. So it's going to look like this when I write it down, -2x squared minus 4x plus 11. Okay, that's all there is to that. Now, there may be follow-up questions like what is the output when the input is -2.5? So an input value is an x value and an output value is a y value. So it's basically saying what is y when x is -2.5. All you got to do is go back to your graph, type in x equals -2.5, hit the intersection. You see it's at -2.5 comma 8.5. 10D says where's the vertex? All you got to do here is just click where the vertex is, and it'll tell you the answer. 10C says what is the input when the output is 7.5? So it's basically saying what is the x value when the y value is 7.5? So type in y equals 7.5 into your graph, and then get the intersections. There'll be two answers because this is a horizontal line. And so -2.658 and 0.658 are my two answers. The next problem says write an equation of a parabola with the following attributes. A vertex is at 3, -1 and contains a point 2, -3. So we're writing it in vertex form, which means I'm going to use the coordinates for the vertex to plug in for h and k, and the other point I'm given, I'll plug it in for x and y. And so when I plug everything in, the letter A will be left behind and I'll be able to figure out what the A is. Instead of it saying y equals, it's going to say -3 equals, here's the -3, A times x minus h, x is 2, and then minus h is -3, and then squared plus k turns into -1 because k is -1. If you use the calculator, make sure you use parentheses. 2 minus 3 is -1. When you square that, it gets +1. So you can write down +1a or just an a, because you don't have to write the 1 in front of a letter when you get 1 in front of a letter. So I could just write down a minus 1 equals -3, and then just add 1 to the other side, and you get -2 equals a. Once you figured out a, then you can write your equation with the h and k and the a plugged in. So you'd write your final answer with the -3 and the -1 left behind. So you say y equals -2 times x minus 3 squared minus 1. So if you ever want to check your work, the graph of this should have a vertex at 3, -1, and it should have this point in the graph there. And if there's any other details, it should also match that. Like usually it'll say it opens up or opens down. This graph would open down because a is negative. So just pay attention to that, because I could give you an equation. If I took this negative away, it'd still have a vertex here, and it could still contain a point there. Just pay attention to whether it opens up or down. Okay, that's all I'm trying to say. Number 12 says write the equation of a parabola with the following attributes. So we have a vertex at 1, -12.5, and it contains the points -4, 0, and 6, 0. So we're going to write this equation in intercept form. So when you're writing it in intercept form, it doesn't matter if I give you the vertex or not. Whatever point that is not an intercept, an x-intercept, has to get plugged in for x and y, because there is no h and k in this formula. So I labeled this vertex as x and y. Okay? The x-intercepts always get labeled as p and q. So x is 1, and so the formula says x minus p, and p is -4. So we'll say 1 minus -4, which turns into 1 plus 4. And then the other one says x minus q, that'll be 1 minus 6, okay? And it'll equal -12.5 because that's what the y coordinate was of the vertex, okay? So this makes 5, this makes -5. That multiplies together to get -25a. Divide both sides by -25, and it'll simplify to get 1/2. So when you write your equation, you'll have a, p, and q behind. So y equals 1/2 times x plus 4 times x minus 6. In other words, you're leaving behind the plus 4 and the minus 6. Okay? You always have to have x and y in your equations, and then you have to have everything else plugged in. An a, in this one, an a, h, and k, and in this one you need to have an a, p, and q. Okay? So sometimes you can just eliminate answer choices by what the p and q have. So like if these were different numbers for p and q, then you automatically know it's wrong without even having to figure out what a is. Same thing with the vertex form. That's just a test-taking strategy there. So the last problem I want to go over is identifying domain and range. So let's start with these two. These are just normal graphs. You know they're normal graphs because they go on forever. They have these arrows indicating that they're going on forever. And so the domain of any quadratic function is all real numbers. So you could say that in interval form with -infinity to +infinity in parentheses. And then the range, you just need to look at the y-coordinate of the vertex and which way the graph is going. So the y-coordinate of this vertex is -4.5, and it's going up. So in interval form, I'd say -4.5 in a bracket because it's passing through that point to +infinity. For a graph that's going down, I'd look at the y-coordinate, it's 6, but that's going to go second because it's going down towards -infinity. And interval form always has to have it written in order from least to greatest. So put -infinity first to 6, all right? So 6 is the highest point it can go. If I give you a function, you can still automatically say the domain is all real numbers. And then what you want to do is you'll want to graph this function. So here's a snapshot of the graph, but we can just go into decimals right here. And you can type it in with the f of x equals or without it. It doesn't really matter. But here I have it typed in just how it is. And so just click on the vertex. -4.5 is the vertex, or the y-coordinate of the vertex, I should say, and the graph's going down. And so I can write my range answer as -infinity to -4.5. Just remember, if the graph's going down, it has to have -infinity coming first. If the graph is going up, it has to have +infinity going second. Okay? Maybe that helps. You may have a special case where there's a restricted domain and range. You know it's a restricted domain and range when there's a clear start and stop point, and there might even be a word problem attached to it, letting you know some additional details. Like this says human cannonball. So I guess if you're like at the circus and they launch someone out of a cannon, this would be the map of their trajectory. But you see there's no arrows, like this one has arrows. There's no arrows going off for infinity. So it starts here, ends there. All right. So this domain will not be all real numbers because there's a clear start and stop point. But domain moves from left to right. So what's the leftmost point? Look at the x-coordinate of that. So that's 0. What's the rightmost point? Look at the x-coordinate of that. That's going to be 90 because this is going by tens. So I need to use brackets because it's passing through 0 and 90. But yeah, that's all I say for my domain. And then for my range, you look for the lowest point, and you look at the y-coordinate of the lowest point, and you look at the y-coordinate of the highest point. So the highest point's up here, 50, 35, and the lowest point is here, 0, 15, so I'm going to use the 15 and the 35 to write my range. A common mistake people make is they look at the rightmost point for the range value as well, but range is concerned with up and down movement, okay? So that's why this range has to be 15, 35. So yeah, that's a special case when the domain is restricted. More times than not, you get asked questions about regular graphs or regular equations, okay? So that's going to wrap it up for the review. Thank you for watching. Hope this helped. Good luck on your tests, and goodbye.